with a little energy method. Two particles PQ, P 2.5 kg, Q 0.5 kg, light in a stable string. Okay, angle 30 degrees, P on the plane, Q hangs 2 meters below, P released from rest, and coefficient of friction. Find the acceleration of P. So first of all, we need to know the forces acting. So for Q, we have the weight downwards, m times g. For P, we have the weight downwards, this is wp, which can be split into w sine and w cos, because if you look at this triangle, this is 30 degrees, this is 60 degrees. If this is 60 degrees, this is 30 degrees. And if you draw the triangle, this is right angle triangle. The hypotenuse is w, and this is the adjacent side using cos, and this is the opposite side using sine. Right, so we have w sine, w cos. If you want to find the number here, w sine would be mass times g times sine 12.5. Now to find the direction of the friction, look at the w sine in this direction and the w of q. Obviously this is bigger, so that means if there is no friction, the object will move in this direction. So that means the friction must be opposing that motion. The friction is going up the slope. Now to find the friction, we need to find the normal reaction force. To find normal reaction force, we need to use the FBD of P in this direction. So the FBD of P, sigma F equals 0 in this direction, perpendicular to the slope. We have only two forces, R and W cos. So the normal reaction is WP cos. For the friction, now we know the R, mu times R. So this is the R. So use your calculator. This is the friction force up the slope. So now to find the acceleration, we use the FBD of all. So to find the FBD of all, we need this kind of diagram here. So sigma F equals ma, because there's an acceleration. So again, this is heavier, so acceleration is down the slope for P and vertically upwards for Q. So for this weight force, because this is opposing this A direction here, that's why this is negative, -5. And this friction force, again opposing this A direction, also negative, -5 root 3 over 2. And this weight component of P is also down the slope, same direction, it's positive. And since this is FBD of all, we use the total mass and just divide both sides by the brackets here, use a calculator, we get the acceleration. And notice that we don't care about the tension because they cancel out anyway, so this is the fastest way to find the acceleration. Now use energy method to find the speed of the particles when they are at the same vertical height. So again, Q is moving upwards, vertically upwards, P is moving down the slope, and initially they are 2 meters apart vertically. So as the Q is moving upwards, let's say a distance d, because we have the same rope and it is taut, this means the distance down the slope is also d for P. So d is moving down the slope, so the diagonal distance is d. If you look at this triangle here, this is 30 degrees from horizontal, and we have the hypotenuse, which is d. We are looking for the opposite, which is h. So the h, the vertical distance downwards traveled by P, is d sine 30 degrees. So the d is going up, the Q is going up, the P is going down. This distance is d, this distance is d sine. So the total is supposed to be the 2 meters. So that's why we do d plus d sine. So this d vertically upwards, this h vertically downwards, in total should be 2 meters. So we factor out the d. 1 plus sine 30, use a calculator, you get 3 over 2. Multiply both sides by 2/3, you get the d. So again, Q is moving upwards, 4 over 3 meters. D is moving in this direction 4 over 3 meters, but the vertical distance 4 over 3 times sine 30 degrees, that is 2 over 3. 4 over 3 plus 2 over 3 is 6 over 3, which is 2 meters. Okay, that is the D. Now to find the velocity. Okay, so energy lost equals energy gained. So the energy lost is because P is going down the slope. It is losing potential energy. So P is losing potential energy, and Q is going up vertically. It's gaining potential energy, and both P and Q are moving because the same rope moving at the same velocity. So we have gain in kinetic energy, and we have thermal energy here because of the friction. Friction makes things warmer, so we have the friction force times the diagonal distance for the thermal energy. So now we plug in the numbers here, or actually we can do the algebra first. So subtract these terms from both sides, so move it to the left, and then we divide both sides by this thing here, and then we take the square root, and then we plug in the numbers. We have the mass of P, the G. Remember the H is D sine, so this is the vertical distance traveled by P downwards. This is the H, and this is the D, this is the F, the D. I just plug in everything, use a calculator, we get the final answer. Alright, I'll see you again next time.